We're all used to seeing incredible images from our cosmic backyard, neighboring planets, their moons, comets, and asteroids.
But it wasn't that long ago that places like these were nothing more than points of light through a telescope.
So how do we get from here to here? Well, it wasn't easy.
It took hundreds of thousands of people of diverse backgrounds and expertise working across disciplines and extending through decades.
Perhaps people don't always realize is just the enormous number of people involved in these missions and all the different kinds of skills they have.
You know, in order to make these planetary science missions work, it takes thousands of people.
Well, NASA is a very diverse place.
I'm a geologist. I work with people who are, atmospheric scientists.
You need someone who's skilled in molecular spectroscopy.
Geochemists.
There's mineralogists.
Folks who are skilled in measuring magnetic fields.
There's a lot of different ways to contribute to these missions.
We need the engineers to build the spacecraft.
Mechanical engineers, electrical engineers.
We need people that know the optics.
Software people.
All kinds of people who study science, technology, engineering, math.
If you're passionate about space,
there's no one particular type of person that works on any planetary mission.
And as long as you have some other talent,
you get a really interesting diversity of backgrounds and expertise.
Then we need you.
This is an exciting way to use those skills to explore something that no one's ever explored.
Let's just start 50 years ago. Everything we knew about the solar system came from the back end of a telescope.
Nothing more than fuzzy pictures from even the largest telescopes.
We were putting together a picture of what are our planets, what's the inventory of our solar system, and we found the asteroid belt and the 9 planets at that time.
We've come an enormous way in 50 years. It's unbelievable the kinds of things we've discovered.
We've come from an era of pure science fiction to an era of unbelievable science fact, science reality. We have bridged that abyss.
In every young person on the planet we have wanted to know and do what we were doing.
Those first flybys and encounters with planets were basically done with good engineering with our scientific eyes wired shut.
And you were assured that whatever instrument you built, you're going to find something new.
To go from the very early steps of just being able to get something off the launch pad in Florida, away from the Earth, on the right trajectory to get to Venus or Mercury or Mars.
I think all of a sudden, we were really opening a new window on our universe.
The new age of being there at planetary exploration opened with Mariner 2, a mission to the planet Venus.
Now prior to that, we had 4 lunar missions that failed, and Mariner 1 didn't make it either.
The reason Mariner 2 got to Venus is because Mariner 1 had to be blown up by the range safety officer a few seconds after launch out of the Cape.
So Mariner 2 flew by Venus and discovered a number of things that are incredibly important. For instance, it found out that Venus didn't have a magnetic field.
Venus is a really inhospitable place.
The clouds are made of sulfuric acid. It's got runaway greenhouse gone wild.
The highest temperatures of any planet in the solar system, actually even runs higher than the hot places on Mercury.
You can melt lead on the surface.
It actually spins backwards, rotates backwards.
That temperature is evenly distributed around the whole planet, not only on the day side, but on the night side of Venus too.
You have to start somewhere, and so that was an incredible accomplishment just to be able to get away from the Earth and have everything work properly.
Mariner 2 opened our eyes to the diversity of possibilities in the solar system, because before Mariner 2, people thought Venus might be a place that was almost hospitable.
Up until that point, there was a lot of science fiction that there could be beneath the clouds a very tropical, Earth-like environment.
Those first instruments from that first flyby showed us a real planet that was different, hotter, more challenging, and no less interesting.
Venus is so similar to Earth. Venus is similar in size, similar in mass, similar in location in the solar system. It should be very much like Earth, and yet Venus is nothing like Earth.
Really, what is the real Venus? We don't know. And so, in today's era of planetary exploration, Venus remains one of the big enigmas, and one of the places where a lot of planetary scientists think we have to get back.